Hello student. Now we'll discuss about elements, compound and mixture one by one. Elements, compounds and mixtures. What are the elements, what are the compounds and its property and mixtures? So basically, if we talk about elements are those compounds, those substances in which each atom is made up of, in which every atoms are of similar kind, same types. Elements are the substance in which elements are the substance in which you have or we can say which are made up of same types of atoms. For example, for example, if we talk about its example, sodium, potassium, phosphorus. For example, if I'm talk about the sodium, its symbol is Na. It is made up of same type of atoms, just like the all atoms in the form of dot I'm showing. So these are all made up of similar kind. It means same type of atoms. These groups of atoms, for example, if I'm talking about the same type of atoms in it, same type of atoms in it. So these are the elements. And if we talk about just like just like the same things of sodium is in potassium, phosphorus, any element we can consider, the atoms are found in that particular elements are of same type of atoms. Okay, so these are the elements. Elements are basically, we in previous chapter we have discussed about the elements. Elements are basically classified into three types. Elements we just classified into three types. First one was metal, second one was non-metal, non-metals, and the third one was metalloid. So what are the metals? Metals are usually electropositive in nature. Metals was electropositive in nature. It means it can lose electrons. Non-metals was electronegative in nature. It can have a tendency to gain the electron. And metalloids shows properties of metals and non-metal. Shows properties of metals. Properties of metals and non-metals both. So these are the basically classification, and if we talk about the physical appearance, the classification of these elements on the basis of physical appearance, metals are sonorous, ductile, malleability. It means it can stretch in the form of wire of a metal, just like a gold, a long wire, and thin sheet, just like a malleability. Malleability is a phenomena to convert a metal into thin plate of sheets, and the sonority, it means it has some sound producing effect, and so many things. Just on the basis of physical classification, we can classify the metals and non-metal which don't show these properties and are mostly electronegative in nature. and metalloids just show properties of metals and non-metals both. So these are just the properties of these are just classification and properties of elements we just discussed on here. Now come to the next point is just compound. The most informative thing we will study in it. The compounds. What are the compounds? The compounds which are made up of fixed proportion of two and more than two elements. These are the substance. These are the substance which are made up of the atoms and molecules of two or more in a fixed proportion fixed proportion proportion. Why did you discuss the fixed proportion on here? Fixed proportion means it is found in a definite proportion which is required. For example, if you just talk about the gaseous compound like CO2, why just the oxygen is 2 and carbon is 1? In this oxygen atoms are 2 carbon in 1 because its nature is all its nature is found in this category concluded two oxygen atom and one carbon atom. It means the amount of masses of these two elements, carbon and oxygens, are fixed in the compounds. And it means fixed or definite, we can use the word on here. So it is the fixed proportion substance. Now, if we talk about the calcium carbonate, next example if we take, so oxygens are 3 and carbon is 1 and calcium is 1. So, according to definite mass proportion, according to the law of definite mass proportion, the oxygen, carbon, and calcium contain fixed mass. These contains a fixed mass, and in each molecules of calcium carbonate the fixed mass is found, which is by the law of multiple proportion. And what is the law of multiple proportion? Law of multiple proportion says that whatever the number of elements of atoms are in a compound, their mass is remains same from wherever the source these are obtained. It means from which source you are obtaining the named given compound, you just find the same mass everywhere from whatever the techniques you are synthesizing or getting from the natural resources. Their mass remains same according to law of constant proportion, sorry, law of constant proportion, this was say. And law of definite proportion says that their masses of the elements in a compounds are in fixed proportion, in a fixed ratio. So this is the basically the definition of compounds. And what are the mixture? If we talk about the mixture are usually the it we can say the composition of two or more compound, but not in a fixed proportion. We can say composition of two or more compounds, but not in a fixed proportion, fixed proportion. This is called mixture. For example, whatever the mixture, air is the mixture. Yes, air is the mixture. So many gaseous compounds are present in it, and nitrogen, oxygen, carbon dioxide, normally gases are present in air. And or we can say, some other examples like sand. In sand so many elements can be found. And for example, soil. Yes, so these are the mixture. Easy. So mixture composition to more compound, but sorry, but not, wow, what the silly mistake I've done, sorry for that, but not in a fixed proportion, not in fixed proportion. It is not found in a fixed proportion. This is a basic line, not in fixed proportion. It is not found in a fixed proportion, that is called mixture. So here, and mixture here, now will we have discussed in last lecture, the mixture is classified into two main categories. So what are the two main categories of mixture? Here we go, we'll discuss. The mixture have two main categories, that is the homogeneous and heterogeneous. The first one is homogeneous mixture. Homogeneous mixture. And the next one is heterogeneous mixture. Okay. Homogeneous mixture in this, like just like a true solution examples, we can say the true solutions. What are the true solutions? True solutions are those in which solute particles are completely soluble in given solvent. These are called true solution. For example, if we take example, the solution of the mixture of water and salt, or we can say mixture of water and sugar. Whatever the example we would like to take, we can, both examples are water and salt. This can be the suitable example of the homogeneous mixture. And what are the heterogeneous mixture? Heterogeneous mixture are again classified into two main categories. These are the suspension and colloids. These are also categorized in two categories, that is the suspension and colloids. So if we'll talk about the suspension, what are the suspension in it? If we'll talk about the suspension solutions, for example, we can take this definition, we can understand this definition by taking the example like the mixture of water and sand. If we talk about suspension, what is suspension? It is the solution, or it is the mixture in which mixture. Okay, if we talk about the suspension, the mixture, it is the mixture in which the particles of solute. What is solute? In solution, solute is generally referred to that component which are present in less proportion, and solvent is present in more proportion. So by the combination of solute and solvent, the solution is get formed. So in which the particles of solute means its own particle of solute is not completely mixed, or we can say not uniformly throughout the medium. So is not completely mixed in the given solvent, so we can take is called suspension. And the next thing, it's an important property, its particles are present in bottom after remaining undisturbed for some time. After remaining undisturbed, its solution for some time. It means for some time period, if the solution will we just left it without disturbing its particle, just like we can take an example. If we take the mixture of water and sand like this, and after some time we will say, if we'll take a glass rod and sterilizing the whole solution, the solution is just look like the mixing process, but after remain undisturbed for some time, the particles of solute just like collected at the bottom like this. This is the insoluble residue part. Insoluble residue part of solute. We can say the example, we can say it's example, like example we can say the mixture of water and sand. Water and sand easily. Here we can say clearly this example, water is just like this, and after remain undisturbed, this insoluble residue part like this is just collected at the bottom of the solution in the beaker. If we consider as a beaker as a container, then we'll see the result after some time. So this is the basic suspension. This is the basic definition and the phenomena we just discussed about the suspension. And if we talk about, and its if we talk about the next property is just the type of heterogeneous mixture is just colloids. What are the colloids? Colloids. Colloids, it is the solution whose particle size is less than, its particle size is 1 to 1000 nanometer between. It is it is a heterogeneous solution. Oh sorry, it is a okay. It's a heterogeneous solution, but look like a homogeneous. But look like a homogeneous. It means it is heterogeneous, but if we see it, it's just look like a homogeneous because its particle size is too small. Its particle size is too small and cannot be seen through naked eyes. Cannot be seen through normal naked eyes. Naked eyes. We can see this thing because its particle size between 1 to 1000 nanometer. Its particles size in between 1 to 1000 nanometers, so small. So we can see that colloids are a heterogeneous mixture. Examples, we can understand the examples. The uh milk, it is also a colloidal solution. And emulsifying paints, emulsifying paints, etc. So we talk, if we just categorize basically the properties of homogeneous and heterogeneous, we can conclude about this homogeneous, and next one is heterogeneous solution. We can have a conclusion about it. What is the main conclusion? We can take the conclusion like this. The first one is it is completely uniformly distributed. It is completely uniformly distributed throughout the solution in the medium. It means completely soluble. Solution in the medium. What is it is I'm referring? I'm referring just particles in the medium. But it doesn't show. It is not. Means it means if we conclude this line in a simple way, completely mixed the solute part in the solvent. Solute in the given solvent. And if we take the conclusion of this heterogeneous mixture, we can take it is not completely distributed, or we can say just not completely, not completely mixed in the solution. So this is the basic fundamental property we just discussed on here about homogeneous and heterogeneous. Its solution cannot be seen through naked eyes. Its solution cannot be seen through naked eyes. Actually, in heterogeneous solution, it is a property except colloid. Colloid solution is the base, shows the similarity of homogeneous, but actually a heterogeneous. Colloid doesn't show the cannot. It's also particle cannot seen through naked eyes, but in heterogeneous, basic property says that its solution particle can be seen through naked eyes. Particles can be seen through naked eyes. Sorry, can be seen through naked eyes. In homogeneous solution particles cannot be seen through naked eyes, but in heterogeneous solution, particle can be seen through naked eyes. So we just easily understand this thing. In day-to-day life activity, whatever the solution you may just made, the solution of water and salt and the sugar, we just see, we observe this thing, it is a homogeneous mixture. And heterogeneous mixture, we take the soil and the sand and the water, we just sterilizing the solution, and after this, after some time, we just see that soil and sand, whatever we take with water, it just settle down in the bottom for after the little time without remaining undisturbed. So these are the things we just discussed about homogeneous and heterogeneous solution and its property as well.